Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 8 to the power of n plus 2 to the power of n is equal to 68, and we will solve this problem for the value of n. So the very first thing we are going to do is, here first I can write this 8 as 2 to the power of 3 and its whole power n plus 2 to the power of n is equals to 68. After this step I can apply here the nice exponential law, and you know that about this law, if we have a to the power of m to the power of n, it is equals to a to the power of n to the power of m is equals to a to the power of m. So it means that if you can interchange these two exponents, then you will always get the same answer, which is a to the power of m time of n. So here we need only to change these two exponents according to this law, so that we will get the output in the form of 2 to the power of n and its whole cubed plus 2 to the power of n is equals to 68. And now we will take little bit simplification here. So now we convert this exponential equation into the polynomial form, so that we will take here y is equals to 2 to the power of n. So when you put y is equals to 2 to the power of n in the above equation, then the above equation will become in the cubic form, and you write it as y cubed plus y is equals to 68. After that we will move this 68 in the left hand side, and you get y cubed plus y minus 68 is equals to 0. And now we rewrite this equation as, here you have 68 and we can write it as y cubed plus y minus 64 minus 4 is equals to 0. And now we make the pair of the equations, which is y cubed minus 64 into or plus y minus 4 is equals to 0. And now we can write it as y cubed minus, here you have 64 and 64 is equals to 4 cubed plus y minus 4 is equals to 0. And now we can use the nice cubic formula, and you know that if we have a cubed minus b cubed is equals to a minus b times of a square plus ab plus b square. So now you can just put here the value of a, which is y, and the value of b, which is 4, in this cubic formula, and you will get the output in the form of y minus 4 times of y square plus 4y plus 4 square, and here you have plus y minus 4, we will write as it is in the form of y minus 4 is equal to 0. After this step you will just take y minus 4 common from both of the terms, and you get y squared plus 4y plus, here you have 4 square and 4 square is equals to 16, and when you take common y minus 4, here you get only plus 1 is equals to 0. After this step we have two cases. The first case is we take y minus 4 is equal to 0, and the other case is we take y squared plus 4y, and here we have 16 plus 1 is 17 and whole is equals to 0. And after this step in the first case you get the value of y, which is 4. And similarly now we find the other real roots from this quadratic equation, so that now first I can check this quadratic equation has real roots or not by applying the discriminant formula. And here you have a is equal to 1 B is equal to 4 and C is equals to 17, and our discriminant formula is delta is equals to B square minus 4 times of A and C. Now I will little bit explain about this discriminant formula. If this delta is less than 0, then we can say that this quadratic equation has no real root. Or if this delta is greater than 0, then we say that this quadratic equation has two real roots. And similarly, if this delta is equals to 0, then we say that this quadratic equation has only one real root. So now we check the behavior of this delta by putting the values of A, B and C in this delta. So now you get our delta. So here we have delta is equal to, this is B square, the value of B is 4 square. So when you put here 4 square minus 4 times of A and C, the value of A is 1 and the value of C is 17. And now you have 4 square, so 4 square is equals to 16 minus 4 times of 17 is equals to 68, and 16 minus 68 is equals to minus 52. And you see that our delta is less than 0, and if our delta is less than 0, then we say that it has no real roots. And if it has no real roots, then we will reject it this case, because here we need only real roots, or we can just solve this problem for real roots. So now here we have only one case, or only one real root, which is y is equal to y is equal to 4. So now we back substitute the value of y. So in the start of the question we have the value of y is 2 to the power of n, so it is equals to 4. And now we write the right hand side, which is 4, as 2 to the power of 2. And now you focus on both of the sides, and you see that bases on both of the sides are same, so that its exponents are equals to each other, and you get n is equals to 2 be the only real root of the given nice equation. So that this is our final value of this question. And now I can check is this root satisfy the given question or not. So now we check. So in order to check, I can write the statement again, and you have a to the power of n plus 2 to the power of n is equals to 68. And you can just put here n is equals to 2 in the left hand side, and you get 8 square plus 2 square is equals to 68. And you know that 8 square is equals to 64 plus 2 square is equals to 4 is equals to 64, and finally you get 68 is equals to 68. So this shows that n is equals to 2 satisfy this nice algebraic equation. So we finally say that n is equal to 2 be the only solution of the given equation, and this is our final answer. So thank you so much for watching this video. Please subscribe to my channel for more exciting videos.